Well, I have a wonderful electronic invention I want you to see. It looks something like this.
Welcome, everybody, to the Dedicated Computing Speaker Spotlight. I'm Gareth Harwood, Director of Marketing at Dedicated, and today we are joined by James Shields, who's a Partner Development Manager at Dedicated, and our Spotlight speaker, Tim Woodard from NVIDIA, Senior Solution Architect. Tim, thank you for being here. You've been supporting Dedicated and our customers as we're all collectively powering the world's most important devices. Tell us a little bit about what you do at NVIDIA.
Sure. Yeah, so I've been with NVIDIA now for about 4 years. I work as a solutions architect on our professional visualization team. And so my focus is primarily with federal customers, DoD and military, primarily in the training and simulation market. That's my background. I spent 20 years developing visual systems for training systems, high performance graphics for flight simulators. And so my experience with developing software for GPUs, I leverage that in helping customers that are trying to do the same today.
Great. Well, on that note, what's happening in the industry? What's changing? If you were going to just simplify it into one major change that's impacting the industry, what is it?
Well, that's a great question. I think the thing that we're seeing most these days is a move towards consolidation. There's a huge desire for training at the point of need, for having more deployable training solutions, for having lower power consumption, smaller footprint, and being able to deliver that training to anywhere from anywhere. The phrase we hear a lot is, the end user wants to be able to open up a web browser and begin training. And that those technologies are now available, and they're being used in other industries. And so kind of where I like to play is as a translator. How do these technologies that are being developed for these other industries and moving very rapidly, by the way, I mean, we're seeing just breakneck pace of new technology being introduced. How does that apply to training and simulation? And that's what I wanted to spend some time talking about today is some of those developments that are happening, how that works with folks like you guys that build these systems that our customers depend on. And then, what are the range of capabilities that they have to use from their toolbox to deliver those very valuable training experiences. So
great. Yeah. Well, if you don't mind, James and I are going to pepper you with questions throughout your presentation. Hopefully that works. And then for those who are listening, there is a Q&A box if you scroll just below the screen here. Tim will answer your questions as soon as possible. It is not a live chat. We're going to be respectful to GDPR privacy rules and things like that. So that is submitted via email, just as a quick housekeeping note. So Tim, why don't you go ahead and take it away? If you want to screen share,
sure.
we can dive in.
All right. So I think as we said here in the intro, there's just a huge trend in moving towards multi-GPU systems. So what I wanted to do was cover kind of the range of those technologies available for building a modern GPU system that's targeted at training and simulation. And what I kind of wanted to tee it off with was this overview of where we've come from and where we are today with the GPU architectures. And one thing that I think is really important to notice is that as these GPU architectures have evolved, it's not just been about increasing memory or increasing clock speed, but genuinely adding new capabilities. And some examples of that along the way have been ray tracing, artificial intelligence, just massive changes to the industries that we address. So anything from computer graphics to AI is now leveraging those capabilities on the GPU. And so, as we look to what's available today with the AMPERE architecture, which was just launched, our professional GPUs for AMPERE, we have the A6000 and the A40, which we'll talk about in a second. So the NVIDIA RTX A6000 is really a game changer for this space. As you can see on the left, just calling out some of the performance increases, they're pretty phenomenal. So from anywhere from 2x to 5x, depending on the type of calculations you're performing. And this ranges from just straight up CUDA performance increases to ray tracing to artificial intelligence. And I did mention before larger frame buffers. That is important. I think to the extent that applications are able to utilize more memory, they'll see significant performance advantages when you have something like a 48 gigabyte frame buffer. And by the way, you can link two of these GPUs together for a combined total of 96 gigabytes. It's just astounding, the amount of scene content that could be loaded into one of these GPUs. And so this as applications begin to leverage some of the other capabilities of the GPU, like ray tracing and higher resolution displays, it's important that the assets are up to snuff too. So that means higher resolution textures, higher fidelity models, and that's where the larger frame buffer comes in. So this is the A6000. It's the flagship of the professional GPU line for professional visualization. And you also notice PC. Yes, please.
Sorry, quick question. With the ProViz series, what's the kind of the one or two key benefits for this product versus some of your other NVIDIA products, especially for training sim and in this market?
Yeah, that's a great question. So, I mean, you can think of most of the NVIDIA products kind of falling into one of a few different buckets. There's the consumer side, which I think most of our customers and certainly that's most of the world is familiar with NVIDIA's GeForce brand, right? So we have our GeForce product line, which is geared towards consumer gaming, where the professional side is a little bit different. And I'll touch on some of these points in a moment. Is in how they're manufactured and in a feature set that's really not of interest to the home gamer. So we put a lot into developing, in particular, software and driver capabilities that are needed for these more complex, scalable visualization solution systems. And some examples of that are synchronizing multiple GPUs. So, you know, on the slide here on the lower right, you can see this has quadro-sync support. So being able to connect multiple GPUs together and have their displays all be synchronized together is a Quadro exclusive capability. So with the A6000, this is a actively cooled board. So this assumes, you know, a certain chassis design, a certain airflow in environmental conditions. Its cousin is the A40, which is a passively cooled version of this board, and it's very similar. About the only major difference is that it only has 3 display outputs instead of 4 display outputs, but it's otherwise very similar. And it also has some hardware secure boot capabilities, so there's some additional security. This tends to be utilized more for virtualization, where the A6000 tends to be used more for active display outputs, but they can both kind of swap roles depending on the need. It's really just about what mode they come in by default. And so that can be changed with a software update. So this is just kind of giving a sense of what's new with the professional GPU line. I just wanted to show kind of visually an image of these different capabilities. These are kind of the 3 major thrusts of what Ampere is bringing. And first and foremost is just many more cores, the SMs. There's now over 10,000 cores, CUDA cores on the A6000 and the A40. And so that allows for just a tremendous amount of floating point calculations to be performed. And that's either for general purpose compute tasks or for computer graphics and running traditional shaders. So just this is where you're seeing those 2x performance increases in traditional graphics and compute. And then with RT cores, you know, these RT cores, they're designed to be able to calculate very rapidly a ray triangle intersection in the scene. And with that, you can compute an accurate representation of how light is bouncing around in an environment. So if you have physically defined materials and physically defined light sources, you can use ray tracing to produce just absolutely stunningly realistic images. And without hardware acceleration, of course, this would be impractical for the kinds of applications that we see in training and sim, where we need to maintain 60 frames or 120 frames a second. So with RT core acceleration, you know, we're able to do literally billions of these ray triangle intersection tests every second. And that allows for a new level of realism that we've never seen in training and sim. And I'm excited to see how this industry in particular utilizes this capability. I think it's really exciting. And then the other is tensor cores. So, tensor cores, if you just explain, the math, it doesn't sound very exciting. It's accelerating mixed precision matrix multiply add operations. What's important about that is that's the fundamental operation of deep learning, both on the training and the inferencing side. And so we're seeing just tremendous capabilities being developed on top of deep learning today. An example of that is with ray tracing, we have the ability to denoise an image. So, only doing, say, one sample per pixel, which would normally generate a very noisy image. We can use the deep learning, a neural network that's leveraging these tensor cores to accelerate the denoising very, very rapidly. And so you can, with the combination of those RT cores and tensor cores, the speed at which these images get produced is impacted. So you had asked kind of the difference between some of the different GPUs that NVIDIA offers, and I wanted to spend a second talking about our professional GPUs, and it's a question that comes up a lot. So we love all our children, so whichever GPU you're using, if it's got NVIDIA on the name, we're definitely appreciative of your business. But there are certain cases where professional GPU makes more sense. And we want to make sure that you guys are aware of what those capabilities are on the professional side. And sometimes, this question about cost versus performance, when you begin to take into account all of the other capabilities that the professional line offers, it becomes a much easier decision. So one of the things that we often see on the consumer side, and you probably noticed it with this AMPERE launch, is there's just tremendous demand on the consumer side for these GPUs when a new GPU architecture comes out. And so it can be very difficult to source these GPUs in quantities of one, much less, hundreds or thousands. On the professional side, it's quite a bit different. So, we work with our distributors and on a forecasted model basis to know what your needs are as a customer to make sure that we actually generate or engineer enough of these boards to fulfill that demand. And so the distribution channel is much simpler when you're talking about the professional side. There's long life cycle. So you may also notice that when a new architecture comes out, the previous gen architecture is no longer available. Well, on the professional side, we'll manufacture these GPUs for many years. In fact, some of these GPUs get used in medical devices like CAT scan machines and MRIs. And the process of going through approvals and making sure that those GPUs are qualified takes longer than sometimes the life cycle of a consumer GPU at all. So having that long life cycle makes a big difference there. Yes, so, please. Yeah,
we're big fans of longer life cycle. Obviously, that is a huge benefit, with the Quadro and such. But if you can just rewind for a second, just regarding ray tracing in general.
Yes.
So we've been talking about it for about a year or so. We talked about it last year at ITSEC. Is there some early adoption happening? How is the market responding to ray tracing in general as a technology, independent of the hardware that's supporting it? Is it being kind of woven in organically? Just what are you seeing out there?
Yeah, so that's a great question. I think the first place that we're seeing that adoption is in the game engines. So you look at Epic, Unreal, and Unity. Both have support now, first-class support for ray tracing. And so to the extent that simulation applications are built using those engines, they may be able to be leveraging those capabilities today. Mm-hmm. I think that the biggest challenge with seeing wider spread adoption with ray tracing in our industry, in the training and sim market, is that many of the software systems that have been developed over now some decades, they've all been built on OpenGL. And for the most part, OpenGL, it's seen a long life. It's over 25 years old now. It's not dead, and advancements happening there. But I would say, going forward, the biggest advancements and things like ray tracing are hitting other APIs. So, from a computer graphics perspective, you have different ways you can different APIs you can use to communicate with the GPU. OpenGL, the other two popular ones are Vulkan and DirectX. And so DirectX and Vulkan have first-class native support for ray tracing. And so what we're seeing right now, I believe, is this kind of slow shift of the ISVs in this space beginning to leverage Vulkan and DirectX, and more so with Vulkan, because it's possible for OpenGL applications to begin dabbling and using a little bit of Vulkan. They can interoperate together. Great. So it's something we want to set the bar high for what's possible, but we recognize that this takes time, especially in an industry like this where you have a lot of investment made in existing software. So, we're here to help educate customers on how to make that transition. We have lots of tools and sample code, and folks that can work with ISVs and explain how to start down that path.
I love that. Set the bar high for what's possible. Pretty cool.
Yeah, and it really is incredible what is possible. You look at what is happening in consumer gaming, and I think that gives you an idea of where this is headed. And I think it's fair to say, in the training and sim world, we're always going to lag behind a little bit what you see in that massive media and entertainment market. But more and more those capabilities are becoming accessible to the smaller shops. So with AI in particular, and we've talked about this in past talks with you guys. With AI in particular, it's kind of a force multiplier where, things that would have in the past taken, hundreds of man hours of manual labor. Well, if you're replacing that now with artificially intelligent algorithms that can accelerate the production of content, like material generation for surfaces, things like that, then, you move into this area where what would have taken hundreds of people maybe now just takes a GPU. So that's I think really exciting. So I don't want to dwell on this too long. We've already kind of covered some of these hardware differences in the professional versus consumer GPUs. What I really wanted to focus in on, and the slides will be available, so feel free to pick through those items at your leisure after we've recorded here. But the software features are where it's at. This is what really distinguishes the professional solution from what you typically see with consumer. We really do invest a lot in software capabilities in the driver that enable some of the things that we've been talking about with respect to consolidating GPUs into server systems and allowing for that training at the point of need. And that middle column in particular is a huge one, multi-GPU support. We see just a big shift in this, and that's not just in the training and sim world. This is across the board. You see it in how computers are being built for the data center, from cloud service providers to HPC. There's just the shift to multi-GPU, and I think in this space, what we want to be able to do is kind of ride the coattails of what's happening in these other industries. They're being made in virtualization and streaming and the server designs, right? So that's really what I was hoping to focus on today, is just looking at where we're going with these multi-GPU systems. And from an NVIDIA perspective, we like to put that all under the banner of what we would call EGX server. So that's where we work with folks like Dedicated to qualify a system. We're not building the computer. We're working with an OEM like Dedicated to build a system that we can then certify is suitable, capable of multiple GPUs. And that's everything from the heat and the power and the form factor. So yes, please.
And the partnership goes full circle, just like you showed in the previous slide. With the software, is like you're saying, is really the differentiator. And really for all of our customers having these complex systems, the developmental time, reducing that time, adding features and getting them to market quicker, really kind of goes full circle with, us both working on the hardware, but having those developmental tools available is just really is the differentiator for all this.
Yeah, I mean, it really does come down to in a lot of ways the software. I mean, as we're both hardware companies, right? We both produce hardware. But when it comes to it, a lot of these challenges, they're what we would call full stack problems. It's not just enough to, you know, provide a GPU and a computer. There's layers of software above that that enable, you know, the unlocking of that potential. And so that's kind of actually where we're headed here. Is I wanted to cover some of the software capabilities that can be utilized on top of a system like this to kind of put it into different flavors, right? We like to think of this as almost like a Swiss Army knife. There's a lot of different configurations from a software perspective that a system like this can take. And there's pros and cons to each of them. So there's not a one-size-fits-all way to use a system like this, but we've worked on many different solutions that address these different use cases, and we can go through some of those now. So one thing I just wanted to cover is that, again, there's not a one-size-fits-all. There's everything from Mosaic, which we've talked about in previous talks, which, you know, that lets you combine multiple GPUs into a single GPU effectively. It's great for things like video walls. There's virtualization, which I want to spend quite a bit of time covering today. And then affinity, that's the other thing I wanted to briefly touch on. And then there's some newer capabilities like multicast, where these are kind of lower level software capabilities exposed through OpenGL and Vulkan and DirectX that allow an application to become natively multi-GPU aware. And so I think we'll see more of that in the future, these applications that understand the underlying hardware even better and are able to fully utilize those resources. And you can see there's a list of questions on the right. You know, there's no one solution that meets the demands of every use case. You really have to balance all of these issues, weigh them depending on how important is latency. You know, if latency is super important, then there may be certain situations where virtualization may not be best. You may need a directly connected display, or if you need synchronization. The bottom one, if you can't change the source code, maybe, you know, if you're a system integrator and you don't have access to the source code, there are methods here available to you that allow you to leverage a multi-GPU platform without changing that application. So, you know, there's a lot of potential here. And so what I wanted to do is kind of just level set with, you know, what we've been doing for many years now, you know, certainly since I've been involved in this industry, since it's gone to PC-based image generation. We've had a single PC for a single display with a single GPU, and you know, this is fine. This works great. We've done well with this for a long time. I think where the challenge comes in with an approach like this is as you grow the number of systems that you're trying to manage. You know, if you have a large simulation facility or even a simulator with a large number of channels. I worked on a training system that had, I think, 26 channels to drive the display system. And that's just for one simulator. And I'm sure there are others that have more than that. As we move to 8K and 120 hertz projectors, you know, they require a significant number of inputs to drive those display systems and keep a frame rate that's high enough for training. So this is where, you know, doing it the way we've been doing it, it's certainly still available, but there are more elegant solutions available these days. And so this is where we're going to talk about virtualization. And so I just to simplify the slides, I've eliminated half the computers. So we're just going to imagine replacing 4 computers now with a single server that has 4 GPUs in it, or 8 GPUs, if you can go that high as well. And so normally you'd have had 4 separate computers, each running their own OS. Well, now we want to run what's called a hypervisor, which you've likely heard of one of these hypervisors before, like Citrix or VMware or KVM. We support all of these. So it's possible with virtualization now, the whole idea, just stepping back and describing it from 10,000 feet, is to take your computer resources in a single system and divide them up among multiple guest OSs. So as far as that OS is concerned, it thinks it's running on its own computer. And so we can divide up the CPUs, the RAM, and even the GPUs in this way. And that brings with it a lot of advantages. So, you know, you look at the pace at which computer hardware has moved, in a lot of ways, it's outpaced the software that we tend to run. So it's kind of rare, from what I see, that we have an application in the VisSim world that just fully utilizes a high-end PC with a high-end GPU. There's spare resources available, and so virtualization is one way that we can increase the utilization of that hardware by dividing up that GPU. So the way we do that is with this vGPU manager software. So that allows the hypervisor to then divide the GPU up, an individual GPU up among multiple guest OSs. And so this is really interesting. It opens up some new possibilities that were not really feasible before. And we'll touch on some of those here in a moment. The key with this virtualization, though, is that we're now no longer connecting the display directly to the GPU. Instead, we're sending that frame buffer as a packet stream over a network to a client device that will then decode those packets and present it to the display. And so, as you can imagine now, your video distribution system becomes a network, and that's quite powerful. Furthermore, all of the data, all of the content, all of the information is stored in the server, in the data center, instead of on the client device. And so from an IT management perspective, this becomes significantly easier to deal with. Updating software, right? You can update the software on a single VM image and then now distribute it to your server. And the next time somebody launches, it's running the latest software. You don't have to go install it on all the client systems. It also enables very lightweight clients. So, anything from like a tablet or a Chromebook with a web browser to a dedicated thin client or a zero client. There are lots of options that can happen on the client end that make it much easier to distribute these systems. So you're no longer carting around a huge rack of server or workstations to deploy a simulator. You can be deploying these thin, lightweight devices, and we'll talk to some examples of that in a moment too. One thing to point out is on the GPU is hardware capability that allows us to do the encoding of that frame buffer into the video stream. In this case, we're showing H.264 for the sending out over a network, and that's really important because it offloads that work from the CPU, freeing it up to do other more important tasks. And this increases the number of users that we can support on an individual system, and it greatly reduces latency. So obviously, when we start talking about streaming, latency becomes a key discussion here. And so again, this is not a one-size-fits-all solution. There are going to be those cases like a fast jet where perhaps this sort of approach where you're streaming pixels over a network is not appropriate, and that's fine. We'll cover some of those use cases in a minute. The point is, you may have a case where streaming with some reasonable level of latency, let's say tens of milliseconds, is totally acceptable. Maintenance training is one example that comes to mind. So lots and lots of use cases for this sort of streaming application. One of the big benefits, though, with virtualization of the GPU is that, as I said before, if you have an application that's really not able to fully utilize a GPU, you can simply add more users and divide that GPU up among those users. And as an example from the training and simulation space specifically, you can imagine a simulator where maybe your host system or your iOS, your SAF, etc., are all running in a VM. And so again, traditionally, this would have been a pretty complex set of computers. We can now, again, use a much higher end server system to deliver that whole experience from a single box. So I think it's a more elegant solution for those cases that merit it. Before I move on to kind of some of the more bare metal type approaches, I wanted to check in with the dedicated guys and see if they had any thoughts on this as far as virtualization goes.
Yeah, I've got a question, Tim. I think I probably know the answer to this, but maybe for audience sake, and I could be wrong as well, but a lot of our customers have a very secure environment, no outside connectivity to the web or internet. And is this applicable to those type environments or not?
Most certainly. So, this is where I think we hear the word cloud thrown around a lot these days, especially in training and sim, talking about, gaming from the cloud or training from the cloud. Most of the time, what we're talking about in when we say that is on-prem. So, I mean, the idea here is that you're consolidating all of the hardware and you're putting it in the back room, the data center on site. And so with a local network, this is a really fantastic solution because you're behind the firewall. All this network traffic for between the server and the clients, you're not having to go out to the public internet. So we're seeing this utilized more and more in the training and simulation community for those kind of use cases. Now it's still obviously appropriate for those cases where you do want to truly use the cloud, but I think more and more. We're seeing this move to having these things available on-prem, and it gets to the other topic we talked about before. It's not just about security, but latency. Typically moving in and out of DoD networks is not the lowest latency, highest bandwidth path. So this is where virtualization on-prem, it gives you a lot of those advantages of what you would normally see with going with a CSP type solution. But you have direct access to all that hardware locally.
Yeah, and Tim, do have a comment. Again, most of our customers are seeing the benefits to this, right? From going from a single pass through and just replicating that to this architecture. So the point is definitely get dedicated and NVIDIA involved early. We do want to have those discussions with you on how to best architect. Set you up for success, picking the right hypervisor and setting up the support. But really, you can see the complexity. The architecture can really just go in many different directions and expand out. So we want to work with you and your applications for this.
That's a super point. I mean, it can't be stressed enough. It really does. It's a full stack issue, right? You don't want to look at any one of these topics out of context. So if you're going to try to field virtualization, everything from the CPUs you select, the amount of memory, the system board and its NUMA architecture, to the GPUs, all of that matters. And so, yeah, definitely engage with dedicated NVIDIA when you're looking to build out one of these solutions, because there are a lot of moving parts. And this is why we do things like what we started talking about with the EGX server, is to kind of qualify these platforms, so you guys aren't out there trying to figure this out all on your own. So that's why we work with OEMs like Dedicated and make sure that these solutions make sense for what you're trying to do. So I did want to touch on a little bit kind of a variation on this theme. So we've been talking about virtualizing the GPU, dividing it up, but there are still those use cases where we need to directly connect a display to the GPU. And as I mentioned before, that comes into play a lot when you need synchronization or you need multiple displays. So think a dome or any kind of multi-display configuration, especially if you need sync. And also, if your application can fully utilize a GPU, then what we can do is utilize a technique called pass-through. And so what pass-through effectively does is exactly what it sounds like. It passes through the GPU, an entire GPU, to one of the VMs, to one of the guest OSs. And so instead of being shared, that OS takes full ownership, and it's just like using a normal physical GPU with a normal professional driver installed. And so from there, you can now have access to those display outputs. You're not networking the video anymore. You have a direct display connection. And one of the capabilities that we introduced recently was the option to have Quadro Sync work in this kind of virtualized environment where you're running a hypervisor, you have separate guest OSs, and you want one Quadro Sync board to be shared among GPUs that are passed through to different VMs. Again, this stuff gets really complicated, and that's why we focus on it on the professional side. These are not the kind of problems that you're typically encountering as a gamer. So this is what we like to work on, is solve these hard problems so that there's a reasonable solution to things like driving a dome from a virtualized environment. So yeah, this is a really powerful way to develop one of these systems, and one of the ways it can be used is for VR, and we've actually shown this at ITSEC before. We wrote a blog a few years back. One of my colleagues, Tom Kay, he worked on kind of coming up with a recipe for building one of these systems, as far as the hypervisor and guest OS and setting up vGPU pass-through and all of that. So definitely recommend you check that out. So we called this system the Mover, stands for multi-user VR. And it's a recipe. It's an example of how you could use a system like this to have a deployable multi-user collaborative VR environment. And it'd be much easier to work with than multiple separate workstations. And then this is where it gets really interesting, is we can start to combine some of these techniques. So you can have the GPU pass-through or GPU virtualization and introduce streaming. We have a capability called Cloud XR, which is really kind of like a virtual HMD driver that sits on the server side, and the software that's communicating thinks that it's connected directly to the HMD, where in reality it's sending the pixels over a network using that encoder and decoder technology that we talked about before. And so this allows us to do some really interesting things. We see a lot of these all-in-one headsets, which are really pretty cool, but they don't have the onboard computational power to generate, super realistic, high-fidelity scenes. But the advantage is that they're tetherless, right? They're tetherless. And so what we can do is utilize Cloud XR to stream content to one of these devices from a high-end GPU server in the data center. And again, that could be on-prem. And the advantage there now is you have this tetherless experience with a super high-fidelity image being streamed to you. And you'd think that this would not work because of network latency and all of that, but you would be amazed at how incredible this experience is. In fact, we've done a lot of work to mitigate that latency that would otherwise, normally if you're moving your head in VR and you don't see the change immediately, it's going to make you nauseous. So we do some amazing things under the covers to eliminate that effect, even if there is some network latency. So pretty incredible, something to check out, especially for you ISVs out there that are focused on fielding VR-based solutions. The Cloud XR SDK is really very cool. And so I'll kind of conclude with the bare metal approach. And this is if we take out that virtualization layer, we have a couple of mechanisms whereby an application or multiple applications can run in a single OS and then communicate directly with one of the GPUs or one or more of the GPUs in that system. And so this is an example of a case where when you maybe do have some control over that software and can author it in such a way so as to communicate with a single GPU, this can be a great solution. And there's a similar capability in Windows through OpenGL and Vulkan and DirectX that allow you to target a specific GPU with your software. We call that affinity. And so, again, from 10,000 feet, we have lots of different options for driving these systems. And the last one is, having one application be multi-GPU aware. I gave a talk at NVIDIA's GPU Technology Conference a few weeks ago. It's recorded. You're free to go check it out at your leisure, where we cover this specific use case in a bit more detail. So, how can you author your application to fully leverage a multi-GPU platform natively? And that's, of course, where the most performance would be possible. But again, this is not a one-size-fits-all. There's many different solutions here, and the one that's going to be best for your situation is going to depend on all those factors we covered. Latency, whether you have access to the application source code, whether you need directly connected displays and synchronization. So, that's a little bit about how, these kind of server systems that we're seeing utilized more and more, not only in many other industries, but now starting to see this in training and sim. Folks being able to leverage these kind of multi-GPU platforms.
That's great. Tim, thank you very much. Hey, we have time for a few questions. I'll just kind of kick that off. And Tim, I don't know, you know our audience pretty well. I don't know what the percentages that are exploring virtualization. Should know that, but I don't. But at this point, where do they go? How do they get started? How do they prioritize that migration to a virtualized environment?
That's a great question. So, first and foremost, we have a lot of great resources online. I think when we talk about virtualization, there's a lot to learn to become expert. And so we have, at our GTC conference, we've posted many talks that cover virtualization. We have a great vGPU documentation website. But then, you can reach out to us as well. And I'm sure you guys as well at Dedicated have some folks that have some virtualization experience too. But yeah, we have an email alias at NVIDIA called quadrosvs@nvidia.com. Quadrosvs, Sierra Victor Sierra at NVIDIA.com. And it's one that we all kind of monitor on the ProViz side. So if there are just general questions about how to field these complex systems as it relates to NVIDIA's technology, we're happy to answer those questions. And a lot of times that's virtualization.
Great.
No, that's great. Well, Tim, thanks for this. Definitely exciting where we are today. You kind of started the conversation of where we, how did we get to this point? From your perspective, what's coming in the next 2 to 5 years? What do we have to look forward to in the many GTCs and NVIDIA in the future?
This is one of those things. If you'd asked me 2 to 5 years ago the same question, I could not have possibly imagined where we are now, and things that have occurred. We have real-time ray tracing now. We have artificial intelligence happening. I think what we're going to see is real growth in those specific capabilities, AI and ray tracing, and the realism that makes available is hard to understand until you see it side by side. Interestingly enough, we utilize these very capabilities internal to NVIDIA. We have this autonomous vehicle division at the company where we're working on building self-driving cars, right? So actually, we're not making the car, we're making the computer and developing the algorithms that will drive that car. And one of the big challenges there is how do you validate that this is going to do the right thing when you put it in the real world? And so the way that we do that, in fact, is a simulator. We built a massive simulator where we build a virtual environment and on a platform we call Omniverse. And this is a software system that's natively used. It can drive multiple fields of view. We can stimulate sensors. And this ends up being very much like a training system, trained pilot or a vehicle operator in the training and sim world. The difference is that we're plugging in an autonomous vehicle. And so now it thinks it's driving in the real world. And then we can, just like you would in a simulator, throw all these different scenarios and conditions like bad weather or a ball bouncing into the street, and see how this vehicle is going to behave, and know for sure when it gets deployed that it's going to do the right thing. And so we're utilizing all these capabilities I've described with ray tracing and artificial intelligence to make a platform like that possible. And I think in the years ahead, you're going to see more and more systems kind of built on that kind of architecture where you have more of a service-oriented cloud-based. And when I say cloud, again, we're not talking about necessarily CSP. It can be on-prem as well. But distributed applications where you have a set of services that know how to communicate on a local network to solve more complex problems. And it's all GPU accelerated. So, what exactly that's going to look like, that's anybody's guess, but it's going to be incredible.
Nice.
Exciting. It is. Tim, can I ask you about form factor and chassis size? And, as you're aware, we have Aura that we launched last year at ITSEC, and we're seeing a lot of demand for that portability, the flexibility within the environment. clearly, I think mixed with virtualized, technologies, are you seeing more and more of that as it relates to the reduction in footprint?
Yeah, so I mean, with form factor, this is one of the distinguishing factors between, and not harp on it too much, but the consumer side versus the professional side. If you look at the different GPU generations that we produced on the professional side, they all maintain a very similar, if not identical, form factor. So when we're working with folks like you that design a server for these GPUs to sit in, we want to make sure the lid closes and that that the sync cables have clearance, and if you're using NVLink bridges, that those things work. That's very important in this space. And so yeah, we do focus a lot on things like the form factor to make sure that for our professional users, there's no gotchas when they go to field their system. So
good. Okay, thank you. Thank you very much. James, did you have anything else? Anything else?
No, great. Appreciate it. And just looking forward to hearing from everyone out there. Love to have these discussions. Where can we take this, and really where can we help you? So contact us.
Definitely. Thank you for watching. Look out for more from the dedicated speaker series, and be sure to enter your Q&A into the Q&A box below, as well as you can find links to the presentation and other resources Tim is going to share with us. Thank you, everybody.
Thank you, guys. Bye-bye.
Awesome.